Let's imagine we are about to make a nice juicy BLT sandwich. Some of those fall tomatoes are coming in, and we're ready to enjoy them. As we build it, we have to make some decisions. What order we're going to put the different ingredients in. Okay, and so we could write it, and let's say bacon's on the bottom. We could put it in order as it's written or as it's said. Okay, but we could also flip the last two, right? So we could have bacon, tomato, and lettuce. We could go bold and put tomato on the bottom. Okay, and that leaves us with two options, right? TLB. And lastly, we could put lettuce on the bottom. Lettuce, tomato, and bacon, or lettuce, bacon, and tomato. Okay, and those are the various options that we have. Now, not too cumbersome to write them all out when we only have 3 items, but as we'll see, it's going to get quite large quite quickly when we add more ingredients. And so we're going to develop a way to mathematically calculate this, and in this case, we are taking some items and we are worried about the order in which we're putting them. Okay, and we're going to call that a permutation. So we're going to build our permutation formula, which allows us to count the number of orders or arrangements that we can put some objects in. Okay, so let's start thinking about how this mathematically is built. Well, for our first choice, we have 3 different, or for our kind of our bottom layer, we have 3 options, right? We could put the bacon, the tomato, or the lettuce. Once we've chosen that, we then have 2 options left for each of, that's not where I wanted that. We have 2 options remaining for depending on what we've chosen first, right? So if we have chosen bacon, we can only choose lettuce or tomato. So we really have 2 choices. And then lastly, depending on what we've chosen thus far, if we've chosen tomato, bacon, we only have 1 option left. Okay, so we in some sense have 3 options, 2 options, and then 1 option. We can think about that a slightly different way to organize it is to say, in our first choice, we kind of build a tree out of this and say we could choose bacon, lettuce, or tomato. Okay, once we've made that choice, again, we have 2 options. We could do lettuce or tomato. Here we could do bacon or tomato. And here we could do lettuce or bacon. Okay, and then lastly, if we've chosen B and L, then we only have T left. Here we would only have L left. LB, T, B, TL, B, TBL. Okay, so another way to kind of visualize what's going on here. Similar in this, what results is the same, right? So we have 3 options, 2 options on this layer, and 1 option here. So we can write that out mathematically as 3 times 2 times 1. Okay, so we have 3 options, 2 options, 1 option. So when we calculate that, we end up with 6. Okay, and that checks out. We had 6 options here, or 6 permutations we could create. So we can generalize this a little bit more, and we'll see that this is going to be helpful because we're going to add in some ingredients here. But the structure remains that we can think about how many options can go in the first slot, then how many are in the second, and how many are in the third, or more generally, the first option you have, the second option, and so on. So let's expand and say, well, I want to include mayo. Okay, pretty classic. We didn't really include that, but oftentimes we have mayo, and let's get crazy and put in some avocado. Okay, so now we have 5 options, and hopefully it'll be clear that pretty quickly we're going to get pretty messy if we try to write them all out. So BLT MA, we could write it down as we have listed, but of course we could then say BLT avocado and then the mayo on top. We could have BLM, we could put the mayo in the middle there, and then we'd have what, T A, and then we'd have BLM M, A, and T. And we already are at 4, and we've just scratched the surface, right? So we could do B, T, and so on. And real quickly, we're going to get a big long list. So how long is that list going to be? Well, using the logic that we built previously, how many options can go in that first slot? We could have bacon, lettuce, mayo, tomato, avocado. So we have 5 options we can put there. Okay, so we have 5. Once we've chosen one there, we then have 4 remaining for the second slot. Okay, once we've chosen that, we then have 3 remaining for the third slot, and then we have 2 left for that fourth slot, and then lastly, if we've chosen the first 4, then there's just 1 left to go. Okay, so we have this many different combinations of all 5 of the ingredients. Let's multiply that out. So there'd be what, 20? So you have 20 options for those first 2 slots. We then have 3 more, so that's 60 and 120, and then times 1 is 120. So we end up with 120 different combinations, or sorry, we have 120 different orders of the ingredients. I slipped up and said combinations. Combinations is going to mean something slightly different, and we'll turn to that in a future video. Here, though, we have an order to these objects or these items, these ingredients, and we could list out 120 different orders. And so it would be quite cumbersome to do that, right? It would be pages long. And so this mathematical concept can help us short circuit that. Now, to help us out as we build some formulas, we're going to use a mathematical concept of what's called the factorial. So 5 times 4 times 3 times 2 times 1 can be written as 5 factorial. Okay, factorial, the way we read this is it's simply that number times each of the integers smaller than that number. So 5 exclamation point or 5 factorial is 5 times 4 times 3 times 2 times 1. That's going to kind of shorthand our equations because, again, just thinking about what if we wanted to think about a deck of cards. Do we want to write 52 times 51 times 50 times 2 times 1, right? Do we want to write all that out, or do we simply want to say this is 52 factorial? Okay, so that's going to be an easy way to summarize what's going on in our math. Now, yeah, so let's look a little closer at this, and let's think about a situation where we maybe aren't going to use all of our items. Actually, let me throw up what is the permutation formula. Okay, and this is just an image from your book, but here we have the permutation formula, and it looks a little bit different than what we've done thus far. What we've done is we've done the numerator. Okay, so we have developed n factorial, where n is the number of objects, right? In our previous example, we had either 3 or 5. So 5 factorial is simply, in this case, the n factorial. So what's going on in the denominator? Well, here we're taking into account the possibility that we might not want to use all of the objects. Okay, so in our example previously, maybe we have these 5 items. So we had, what did we have? We had bacon, lettuce, that's under the, we had bacon, lettuce, tomato, mayo, and avocado, and perhaps we only want to use 3 of these in our sandwich. Okay, and so how many different 3-item sandwiches could we make? Well, again, we could make BLT, but we could also make BLM, BLA, BTL, right? We could list all these out again, but it's going to get quite cumbersome, and so let's develop the math a little further to take into account that we're only going to use 3 of these. Okay, and so let's so what do we have in this case where we're only selecting 3? We have our our logic from the previous example said we could put 5 options, right? In the first slot, we could put so we could put B, L, T, M, or A. Once we've chosen one of those, we have 4 slots left, or 4 options left for the second slot. And then we have 3 options left for that third item. We no longer have the last 2 choices, right? We don't make these last 2 choices. We make the first 3, but not those last 2. And so we no longer have, previously we had 2 times 1. We're removing these. Okay, we're no longer making that choice. And so mathematically, we'd like to remove that. Now, we know quickly how to calculate how many different orders we could put all 5 items in, right? And that's at 5 factorial. But here we want to remove the 2 and the 1. Okay, and so how do we do that? Well, we're going to put that on the denominator. So 5, we want 5 times 4 times 3 times 2 times 1. We're going to divide by 2 times 1. Okay, how do we find 2 times 1? Well, it's the number of objects we didn't select. Okay, another way to think about that is the number selected, the total number minus those selected, or n minus r. This is equal to the number that we didn't select. Okay, in our case, that's 2. We didn't choose the last 2 options. So we can smush this all together, find some open space here, and say what we want is 5 factorial over 2 factorial, because that's going to give us 5 times 4 times 3 times 2 times 1 over 2 times 1. And these 2 and the 1 are going to cancel out, leaving us with the answer we wanted, right? We wanted to, well, now I've made a mess of this, but we wanted to get to 5 times 4 times 3, because we're only making those 3 options. And so this permutation formula does that for us. We take the number of total objects and the number selected, and we can quickly spit this out. So if we wanted 4 of the options or 2 of the options, we could quickly change and plug in the new numbers, right? So if you only want 2 options in here, we would do well, first let's answer our question. It would be 5 times 4 times 3. So how would we finish this calculation? So 5 factorial is 120, right? We just calculated that in the last example. And 2 factorial is 2. And so we're left with 60. Okay, that's kind of gross. We can write that out more cleanly here. Let's say, so we had 5 factorial divided by 2 factorial, and that was 120 over 2, or 60, right? But if we instead wanted to do only 2 of the options, which I guess would leave you with one of those might be mayo and lettuce. I don't know if that's that appetizing, but we would plug in. Well, let's walk through that. So NPR, we simply plug in the number of objects, which is 5, and the number selected, which in our new case is 2. So we would say 5 minus 2, right? And so this bottom part is going to select or take into account how many weren't selected. So we would have 5 factorial over 3 factorial, right? And so that's going to be 120 over 6, or 20, right? And we can see that would end up being 5 times 4, because again, to make this more messy, 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1, we're going to be left with what we were hoping for, just that 5 times 4, right? Where we have 2 options. We could choose bacon, tomato, bacon, lettuce, bacon, mayo. Lettuce, we've discussed the ingredients enough. You get that. So that's how we build and how we use the permutation formula. Now, we're going to turn in the next video to what if we don't care what order this is, right? So this whole process related or revolved around the idea that we were very particular about putting the bacon on the bottom or the lettuce on the bottom, or we cared what order. Sometimes we're not going to care what order. We just want to know kind of how many different combinations we could have. So look for that in the next video.